Today we are going to study about redox reaction. What is a redox reaction? Redox reactions are oxidation reduction chemical reactions in which the reactants undergo a change in their oxidation state. We are going to study about oxidation state a little further. The term redox is a short form of reduction oxidation. All the redox reactions can be broken down into two different processes, a reduction process and an oxidation process. The oxidation and reduction reactions always occur simultaneously in the redox reaction or oxidation reduction reaction. The substance getting reduced in a chemical reaction is known as the oxidizing agent, while a substance that is getting oxidized is known as the reducing agent. We are also going to study about oxidizing and reducing agent a little further. Now look at this diagram. In this diagram, you'll see on the left hand side A and on the right hand side A, one is A positive. You will see that there is loss of electron from the reactants to the product side. So that there is loss of electron and therefore that is known as oxidation. Whereas if you look at the B, one is the blue color B and one is the green color B. So in the product side, you will see a negative sign. So there is gain of electrons. So that is reduction. So a redox reaction can be defined as a chemical reaction in which electrons are transferred between two reactants participating in it. This transfer of electrons can be identified by observing the change in the oxidation states of the reacting species. We are also going to study about the oxidation states a little further. The old definition or the basic definition of oxidation is gain of oxygen and also loss of hydrogen. Reduction is loss of oxygen or gain of hydrogen. So this is the basic definition which we study from grade 9 and grade 10. Now look at this equation. Nickel oxide plus carbon will give you nickel plus carbon monoxide. So if you look at nickel oxide, you will see that nickel oxide is losing oxygen. So there's loss of oxygen taking place between nickel oxide and nickel. So that is reduction. Whereas when you look at carbon and carbon monoxide, you will see carbon gains oxygen. So it is oxidation. So carbon will form carbon monoxide through the process of oxidation. In the second equation, you will see hydrogen sulfide plus chlorine will give you hydrogen chloride plus sulfur. So H2S and sulfur, that is hydrogen sulfide and sulfur, you will see that it loses or loss of hydrogen is there. So that is oxidation. Whereas chlorine and hydrochloric acid, you will see chlorine gains hydrogen. So that is reduction. Now, definition of oxidation and reduction according to loss and gain of electrons. So oxidation involves the loss of electrons and reduction involves the gain of electrons. To study this, we have to write down the half equation of the equation Mg plus O2 will give you MgO. So see what happens. So Mg will lose two electrons and therefore there will be loss of electron and oxidation will take place. Whereas oxygen will gain two electrons and therefore reduction will take place. So this is the third definition of oxidation and reduction. Oxidation involves the loss of electrons and reduction involves the gain of electrons. Now, a very good way of remembering oxidation according to the oxidation and reduction definition by uh, oxidation is losing of electron and reduction is gaining of electron. So this oil rig word will help you to remember it in the beginning, that as you start using it, it sticks to your head and you remember it. So remember the word oil rig. OIL stands for oxidation is losing. So what is oxidation? Loss of electrons. RIG means reduction is gaining. So gain of electron is reduction. Now, oxidation number. So here, what we see is all compounds over here are covalent molecules. Is nitrogen oxidized or reduced? So such questions we will do another process to know whether it is oxidized or reduced. So no, we can't see any obvious like in ionic compound gain or loss of electrons or the loss of electrons as electrons over here are shared because it's all covalent compound. Now oxidation number, charge an atom might be imagined to have. That is what oxidation number. We imagine a charge over there. And unequal sharing in a covalent bond is based on electronegativity difference. That means the element which is more electronegative, the electrons will slightly move towards its side. Now let's go to the oxidation state. Rule to work out the oxidation number. Rule number one, oxidation number of an atom in its element form or uncombined form is always taken as zero. For example, sodium, helium, nitrogen, sulfur, all are taken as zero in their element form. Rule number two, oxidation number of a monoatomic ions equals the charge. For example, sulfur over here with 2 minus charge, the oxidation state or number will be negative 2. Sodium with a positive charge, the oxidation number will be plus 1. So be aware of the presentation of oxidation number. First the sign will come and then the number. Don't get confused how to write down the oxidation number. Always remember, first the sign will come and then the number. Rule number 3. Oxidation number of hydrogen is positive 1 or plus 1 when bonded with a non-metal, but it is minus 1 when bonded with a metal. As hydrides, calcium hydride, it will be minus 1. Rule number 4. Oxidation number of oxygen is minus 2. What is the exception? Except in hydrogen peroxide where it will be minus 1. Rule number 5. Oxidation number of group 1 element is plus 1. Oxidation number of group 2 element is plus 2. Oxidation number of group 17 element is minus 1. Except when combining with element of higher electronegativity. ICI, that is iodine chloride. Here iodine is less electronegative. Chlorine is more electronegative. So iodine will have a positive 1, whereas chlorine will have negative 1. Rules to work out oxidation number. So the sum of oxidation number in neutral compound is 0. So here sodium, chlorine we already know minus 1. So sodium will be plus 1. So overall the oxidation number of this neutral compound NaCl is 0. So that's it. In Na2O minus 2 we know of oxygen. So chlorine, sodium will be plus 1. So overall plus 2 and minus 1 equals to 0. Rule number 9. Oxidation number of polyatomic ions is equal to the charge of ion. For example, the sum of oxidation number of sulfate ion, SO4 2 minus, is minus 2. Sulfur will be plus 6 and oxygen will be negative 2. Now, rules to work out oxidation number. 10. Roman numeral is used to show oxidation number for element with multiple oxidation states. For example, iron 2 chloride, the oxidation number will be 2. Copper 1 oxide, oxidation number will be 1. Likewise, we have oxidation number. We can find out the oxidation number of MnO4. It will be plus 7. So let's do it and just see how we got the oxidation number of manganese in manganate ion plus 7. So let's do it. So MnO4 minus. So we already know oxygen has an oxidation number of minus 2 and Mn we have to find out. So X plus 4, why 4? Because there are 4 oxygen minus 2 is the oxidation number, equals to minus 1, because that's the overall charge. So x minus 8 equals to minus 1, or x equals to plus 7. So now we know the oxidation number of magnet, how it was plus 7. Now let's try to do the oxidation state of uh, chromium ions in potassium chromate. Please pay attention. So K2Cr2O7. So we have to write down the find out the oxidation state of chromium. So we can write it as X over here. Oxygen we already know is minus 2, and potassium group 1, so it will be plus 1. So overall they are 2, so we can write down 2 plus 2xy, because they are 2 chromium, plus 7 oxygen, and minus 2. Overall charge will be equals to 0. So 2 plus 2x minus 14 equals to 0, or 2x equals to 12, or x equals to 12 by 2, or x equals to plus 6. So we now know that chromium has an oxidation state of plus 6. So that's how we can find out the oxidation state of different compounds. I hope this is clear to you. Now, element lithium, sodium, potassium has a usual oxidation state of plus 1. Magnesium, calcium plus 2. Fluorine minus 1. They are no exception, because fluorine is the most electronegative element. So in the halogen group, fluorine, chlorine, bromine, iodine, astatine, fluorine is at the top. It's the most electronegative element. So there is no exception for it. It will always be negative 1. But oxygen over here, minus 2. Peroxide, such as H2O2, it will be negative 1. OF2, where it will be positive 2. Hydrogen plus 1. Metal hydride, such as sodium hydride, where it will be negative 1. H is more electronegative than sodium, and so gains electron control. In chlorine minus 1, when it is combined with oxygen or fluorine, chlorine is less electronegative than oxygen and fluorine, and so loses electron control. So remember these explanation and exception. Now, what is the oxidation number of titanium? So let's find out the oxidation number of titanium. So titanium is titanium chloride, T1Cl3. So we already know chlorine is minus 1, and titanium we have to find out. So we can put it as X. So X plus 3 minus 1, because there are 3 chlorine, equals to 0. Overall charge is 0. So X minus 3 equals to 0, or X equals to plus 3. So titanium has an oxidation state of plus 3. Now let us find out the oxidation state of chlorine in Cl2O7. So let's do it. Cl2O7. So we have to find out the oxidation state of chlorine. So let's put it as X. Oxygen we already know is minus 2. So 2xy, because there are 2 chlorine, plus 7 oxygen, and minus 2 is the oxidation state. Overall charge is 0. So 2x minus 14 equals to 0, or x equals to 14 by 2, or x equals to plus 7. So chlorine has an oxidation state of plus 7. Oxygen is minus 2. Chromium in chromium cyanide, uh, I'm sure you'll be able to do it. We can still do it if we want to, but it's easy. I'm sure you can do it. So cyanide is 1, and chromium is plus 3. Now, class practice, these are questions which can come. So if you look at this, hydrogen has an oxidation. This is sulfuric acid. So hydrogen over here will have an oxidation state of plus 1, sulfur plus 6, and oxygen minus 2. So overall B will be the correct option. In the last one, the sixth question, you'll see D, 1, 2, and 3 have the oxidation state. So they all are present. So they are all correct. So 1, 2, and 3. Now, use of oxidation number. Look at this and the half equation. Now, using electron transfer. Overall equation we already know, and then from half equation, what do we see? Magnesium is losing 2 electrons and oxygen is gaining 2 electrons. So according to this, when loss of electron takes place, it is oxidation. So magnesium is going through oxidation. Why? Because it is losing electron. So definition of oxidation over here is, according to loss and gain of electron, is when an element or a compound loses, usually element loses an electron, then oxidation takes place. And oxygen is gaining electron, it's becoming from O2, it becomes O2 minus, so reduction is taking place because gain of electron takes place. So what is reduction? When an element gains electrons. So what about the change in oxidation state of Mg and O? So you'll see oxidation state of Mg, from 0 it has become 2 plus. So whenever there is increase in oxidation state, we call it as oxidation. And when there is decrease of oxidation state, for example in oxygen, first it is 0 and then it becomes minus, so 2. So there is decrease. So decrease of oxidation state is reduction. So now increase in oxidation number is known as oxidation. For example, from 2 plus it goes to 3 plus, that's oxidation. And in reduction, H2H plus and it becomes H. So there is, from plus 1 it goes to 0. So that is reduction. From plus 1 to 0. So that is reduction. Now look at this equation. Now in this equation, which element is oxidized and which is reduced? So S is oxidized. Why? Because first it was plus 4 in SO2 and then it became plus 6 in SO4, 2 minus. In manganese is reduced. Why? Because it was plus 7 in manganate and then it became plus 2 in manganese 2 plus. So that's the reason why it is reduced. Now this numericals you can these equations you can try by yourself. See, if you practice you become better, so practice them. Now stoichiometry equation showing oxidation and reduction reaction. So overall zinc plus copper ions will give you zinc ions and copper. So if you write down the half equation here, if you look at it carefully, zinc losing 2 electrons, so electrons are lost, it is oxidation. Whereas reduction, copper is gaining 2 electrons because, and therefore it is reduction. Now this practice, you can practice this, deduce the half equation of oxidation reduction for the following reactions. Now, oxidizing and reducing agent. What is oxidizing and reducing agent? We have to be very sure of this definition also. So, how can we define oxidizing and reducing agent? So, first of all, an oxidizing agent, or we also call it as oxidant, gain electrons and is reduced in a chemical reaction. It is also known as electron acceptor. What do? They accept electrons, they gain electron. So we call it as oxidizing agent. The oxidizing agent is usually in one of its higher possible oxidation state and it will gain electrons and be reduced. So remember that. So itself it is reduced. By gaining electron itself it is reduced. Reducing agent, a reducing agent, we also call it as reductant. Usually they lose electrons and is oxidized in a chemical reaction. It is typically in one of its lower possible oxidation state and is known as electron donor, just the opposite of oxidizing agent. A reducing agent is oxidized because it loses electron in the redox reaction. So itself it gets oxidized. Now deduce the oxidation and reduction half equations. Deduce the oxidizing and reducing agent. So let's write down the half equation and find out the reducing and oxidizing agent. So first question, Mg plus Cl2, we can write down the half equation equals to Mg2 plus, loses 2 electrons. Chlorine gains 2 electrons, forms 2Cl minus. Now Mg is the reducing agent. Why is it the Mg is the reducing agent? Because it loses electron, therefore it is the reducing agent. Chlorine is the oxidizing agent. Why? Because it gains electron. Next one, NaCl plus iron, F2, sorry, fluorine will give you sodium fluoride plus chlorine. So if you write down the half equation, chlorine, Cl minus, and it will gain 2 electrons, it becomes Cl2. And fluorine, we'll see, it will, sorry, chlorine over there is losing 2 electrons, and fluorine over here is gaining electrons. So NaCl is the reducing agent. If you overall look at NaCl, it's a reducing agent. And F2 is the oxidizing agent. Why is F2 the oxidizing agent? Because it is gaining electron. Fluorine is gaining electron, and chlorine over there is the reducing agent. Why? Because it is losing electron. So remember that. Now next, last copper sulfate plus zinc will give you zinc sulfate plus copper. Now copper, Cu2 plus 2 electrons, it will gain 2 electrons and become copper. Zinc is losing 2 electrons. So copper sulfate is the oxidizing agent over here. Why is copper sulfate the oxidizing agent? So overall we see that it is sulfate is copper is gaining electrons and becoming copper. So it's the oxidizing agent. Whereas zinc, you'll see, is losing electrons. It loses, so it is the reducing agent. I hope this much is clear to you. So practice more questions, and as you practice, you will become better. So it's not difficult when you practice and learn it. So I hope you understood this, students. If you like my videos, please subscribe and share with your friends. And please